In this video, I'll do the solve examples of exercise 7.3. We are doing the first example here. As you can see, it's given here in this figure, the length of OA being equal to OB, and the length of OD, this is OD, is equal to OC. We have to prove these two lines as parallel, right? So we have to prove this line, say right, I've done something wrong here. We rewrite this. So I have to prove parallel AD. Yeah, that's right. AD is parallel to BC. Yeah, we're correct. So this is AD and we have to prove parallel to BC. As you should know, in this kind of situations, when you have to prove two lines parallel, we can prove any of its one pair of alternate interior angles as equal. Either you prove this is equal to this, or you may prove this angle is equal to this angle. This way, we can write the lines as parallel. And as you know that when you have these two angles belonging to two different triangles, we prove these two triangle congruent first. So once we prove these two triangle congruent, from CPCT, we can write this required angle as equal. So let's write down the triangle here. The two triangles that we are proving congruent is triangle AOD in triangle, the below one, that is AOD. And the other triangle here is this triangle BOC. Right. In this triangle, we have already been given, that is AO is equal to OB. That's from given. We have been given OD from the first triangle is equal to OC. These two information are given. Moreover, you can see in the figure that these two are vertically opposite angle, and vertically opposite angles are equals when two lines intersect. So we'll write angle AOD is equal to angle BOC, and that's from vertically opposite angles. So once these three elements are proved of this triangle, we can write therefore the triangle AOD as congruent to the triangle BOC. And these two triangles are congruent by side angle side. As you can see, the angle is in between the two sides. Now, once we prove this true triangle congruent, I can write this angle, say this angle A is equal to angle B, right? Angle A is equal to angle B. This is angle B here, B, and that is from CPCT. Now, something that comes to a student mind, that why not angle A is equal to angle C, why it's B? So when you look into the triangles, it's correspondence, right? As you can see here, A corresponds to B, right? And not C. And that's the reason these two angles are equal. And then you'll write that, since they are alternate interior angles, right? These are alternate interior angles, right? With respect to this is ADBC, AD and BC. So we can write therefore that AD is parallel to BC, and that's how it is proved.